Well, my dear students, now we are going to start the next lecture on rolling processes. In the previous lecture we covered the basics of rolling, the different types of rolling processes, and a little bit about the very simple analysis when you calculate the rolling load, power and torque of the motor required, etc. And the different very common defects that we come across in rolling process. In this lecture we are going to cover some of the rolling practices that is being followed in rolling mill, various kind of rolling mill, especially flat rolling and shape rolling, etc. And we would also see the other rolling processes like ring rolling, thread rolling, etc. The purpose of this lecture is to further introduce the other issues of rolling, so that you all are aware of the complexity of the rolling processes and the applications part. So, you know the flat rolling where the two rolls are there, and you are going to reduce the thickness of the long workpiece. And the shape rolling where you come across different shapes like I section, rail section, etc. And the third category that falls we would discuss is the production of seamless tubings and pipes is another area you can produce it by rolling process, seamless tubes and pipings. You know that the plates that has thickness greater than around 6 mm we call it as plate, right? And when we call it sheet, when the thickness is generally less than 6 mm we may call it as sheets. So you know that the ingot is converted into blooms, then bloom is converted into sheets, and billets, etc. So one should know the difference between plates and sheets when we come across rolling. So as I said, the plates when the thickness is less than 6 mm, and it will be called as sheets when the thickness is less than 6 mm. If it is greater than 6 mm it is plate, right? Look at this flat rolling process. So this picture depicts you the very common a rolling mill where a flat rolling is used for converting a slab into a cold rolled coil, right? You all might have seen coils of cold roll of around 5 ton, 6 ton coils, most often you might have seen. So look at the first process. These slabs usually comes from the continuous reheating furnace, and that may be a tunnel furnace, as last time I explained you. So these slabs of a given thickness and of a given temperature, because these slabs are very thicker and it is kept in a continuous reheat furnace where it comes out for rolling. So, these slabs, as you see the red one, it passes through the scale breaking unit first, because these slabs has got red hot, very red hot. If it is steel one, then one may expect around 1400 to 1500, 1200 to 1300 degrees centigrade, and therefore, when it passes through the atmosphere towards so lot of scale, so that scale is to be removed, and that is how we have a scale breaker. So, once it passes the slab through the scale breaker, all the scales on the upper surface, lower surface and the sides all are removed, and then it passes through the roughing mill. As I told you, when you come across a rolling process, generally it is a 3-stage process. First the roughing passes, the intermediate passes, and the third is the finishing passes. So, the roughing passes through heavy reduction, then the intermediate process has got a medium reductions, and the final pass that will give the final shape and size and thickness of the plate or sheet is called as the finishing passes. So, look at this, after scale breaking it passes through the roughing mill. Further, this roughing mill may have many stages, like here you see it is a 3-stage. First, because these slabs are very thicker, more than 6 inch, so it will pass, then it will reduce one by one, and it will come to the finishing mill or intermediate mill. Basically, here it is treated as finishing mill, but the finishing mill you can see it may be the 2 stage after at the inside, otherwise all 1, 2, 3, 4, 5 stages could be 4 to 5 stages could be of your intermediate mills, right. So, once it comes out, there is enough cooling, and this process from the slab to the when it comes to a considerable size thickness into the coiler, we call it as the hot rolled coils. So, we from the slab we get the hot rolled coils, right, and these hot rolled coils would be used for further treatment process, because its mechanical properties are changed after hot rolling. So, these hot rolled coils are sent to continuous pickling line, where the pickling process, that means cleaning of the surfaces, upper surfaces, lower surfaces, and is removing of the dirt, etc. it takes place, and then it is sent to the tandem cold rolling mill. So, cold rolling mill will further reduce the thickness, and once a considerable thickness it comes, then it will send to the continuous annealing mill, because after cold rolling the mechanical properties it becomes slightly harder. So, that has to be annealed further, and it passes through the annealing continuous annealing line, as you can see here. It passes through the initial preheat, and then it passes through the annealing line for the cooling, and then finally it is again rolled back, and that we have the cold rolled coil. So, we from the slab we obtain hot rolled coil, then these hot rolled coils are further used after cleaning and etc. That is the pickling process in the tandem cold mill, and this tandem cold mill, whatever we get the output, it is further cold rolled, right, through after annealing, and these cold rolled coils becomes very important for us. So, these cold rolled coils can be further used for varieties of products, like one can use it for electrolytic cleaning. So, first these cold rolled coils are taken and it is used after electrolytic cleaning line, it is then again it may be further reduced, or you can batch wise anneal the furnace, and you can then temper, and then you can pass through the tempering mill and you get the cold roll coil. So these cold roll coils you can get through these routes. The first route, that may be the continuous annealing line. Second rule, when you can through it the electrolytic cleaning line, and then slight tempering, and then you can get the cold rolls. These cold rolls may be of 10 mm or 1 inch thick, 10 mm, 5 mm, 3 mm, 2 mm thick, whatever you want. Accordingly the rolls you can have from the market. Alright. So if this is what's the basic flat rolling. So flat rolling process, if you have that you have seen, you have a metal strip that enters the roll gap. The strip is then reduced in size by the metal rolls, right, and the velocity of the strip is increased, the metal strip is reduced in size. Factors that affect the rolling process are the frictional forces, roll forces, and power requirement. If you look at the basic, if you analyze it, this is what's the workpiece, and when the contact is shown, the width, final width, and the initial width WG, H0 is the initial thickness, and the HF final, the roll contact length L, the radius of the roll, and the V0 is the initial input velocity, and Vf is the final velocity that comes out. These are some of, if you look at the other view of the same, you have the, and you know that there should not be any slip point. So slip point, no slip point is the what? It's the neutral point, as I said earlier. You look at the V0 and Vf that you have, and the friction directions at the neutral point, just to recall it, and the same thing if you look from the other view. That's the simple 3 stages to show you A, B, and C, the 3-dimensional, the side view, and the front view here. So as far as the frictional force is concerned, I told you the frictional force that acts on the strip, the forces, if you look at this here. So the maximum draft is what? If you look at the previous figure, H0 minus HF, that's the maximum draft, and that should, as I told you earlier, it should be nu square R, where R is the radius of the roll, and the roll force as previously determined, capital F, has been W0, capital L, and Y average, and L is the contact length, that is the square root of R multiplied by H0 minus HF, that's the we have covered. So in flat rolling practice, as far as the hot rolling is concerned, the initial breakdown of an ingot and then the continuously cast slab is used generally. The structure may be very brittle, and that has to be, it converts the cast structure, so in flat rolling, to a wrought structure, and where you have a finer grains and enhanced ductility you find, and you have to, so when you apply the flat rolling, you have to reduce without any defect, right. So that happens in hot rolling. In continuous casting, when you obtain the ingots, that is replacing the traditional method. So however, the continuous casting is faster and better, no doubt, but the before the products of the first hot rolled operation, we call it as bloom or slab, you know. So the square cross section of around 150 mm, and that is around 6 inch on one side, and it is processed further by the shape rolling, where you can convert into I beams and railroad, etc., as said earlier, right. So billets, if you are using billets, so which is smaller than the blooms, and it is rolled into bars and rods. So if you follow it by the cold rolling flat way, so this process carried out, it is, as you know, it is carried out at room temperature, and it produces sheets and strips of metals, subject, and with comparison to the hot, it has a better surface finish and has got less scale, right. Uh, as far as the pack tooling, when the two or more layers of the metal are rolled together, we call it as a pack rolling. See, if there are only one sheet, you may also try with the two or more number of sheets simultaneously and roll it. This is what is called as pack rolling. So you know, whenever we discuss rolling, right, there is, in the rolling process, there is always change in the grain structure, and is that too specifically in hot rolling, there is a grain structure changes takes place. Like if you see in the A, where you have an ingot with the non-uniform grains, you can see, and once it is hot rolled, you can see that we have the wrought product with large grains, like so what happens, you can see the elongated grains which is deformed, and and then the new grains are formed, you can see, and the new grains grows from its previous one, and again in hot process the recrystallization completes, and you result into the wrought products with the small and uniform grains, you can see. So this shows the usual grain modifications, grain changes during the flat rolling process. So you have a initially you have the ingot which is non grains, then when you roll it, the wrought products with the large grains, and then you result into wrought products with small uniform grains. So that's the makes the importance of the rolling here. Now you look at this shape rolling process. What happens in shape rolling? As you see, the rollers has got groups, different types of groups, so that when the sheet your product passes through, like if you see the first stage where we call it as the blooming rolls. So blooming rolls will pass, once it passes, it will give a initial shape, we can say, and then when it comes to the second shape, that we call it as the edging, we can say edging rolls. So the edges are modified, and in the third stage you have the roughing, are horizontal and vertical rolls are there. So you can see the horizontal rolls as well as vertical rolls, to that is called as the roughing one. In the fourth stage, this sequence of for producing a particular rail kind of shape, it is going to pass through these 6 stages. Okay, so this shows the stages in shape rolling of an edge section, edge section rather part. So various other structural sections such as channel sections and I beams can also be rolled by this process, which is called as shape rolling. So if you look at the third stage, fourth stage, then we have the intermediate horizontal and vertical rolls that will produce next stage, and then again the fifth stage will be edging rods. So edges will be formed, and finally which is called as the finishing, which has got horizontal and vertical rolls both, for providing the final finish of the edge section. So, this 6 stage especially for edge section has been shown, and likewise one can design the other for other shapes also the stages. In flat rolling practice, as you know, you use flattening rolls. You use flattening rolls where there are leveling rails are as it is shown, and because it has to be flattened, once it passes through there may be some wrinkle, so you use another set of rollers apart from, so that it gets a seat of flat seat, and this is what the arrangement has been made in A and B. There are many roll arrangements, as you can see here, the combination of 2 rolls only, then the combination of other rolls like 3 rolls and other rolls, and combination of other rolls. So, this is what the various roll arrangement is shown. You can see they is starting with the 2 roll, 3 rolls, 4 rolls and multi rolls. So, multi rolls, last one that we say, it is a Sands mill we call, and generally it is very popular for cold rolling of thin sheets of high strength material. So, these are the other types of flat rolling practices where you follow. As I said, the defects earlier, if you recall, there are defects and it is not expected. So, in case of rolled plates and sheet, again there are defects. So, what are not desirable, that is undesirable things, the degrade surface appearance. So, even the surface that is going to produce after rolling, it should not be bad, and it should be adversely affect, it should not affect the strength as well. In case of the sheet metal defects like the scale, rust, scratch, gouge, pits and cracks, these are all the kind of sheet metal defects that we come across in rolled plates and sheets of processes. And this may happen because of the impurities and inclusion as well as blisters and all those things. There are many defects. Webbed edges are also formed, which is because of the roll bending. Alligatoring, as I said, it may be where the D case, if you look at, this is very complex phenomenon where the sheet from the middle it gets separated likewise. So, and there is the B case where the edge cracks in C, the B where the center line you develop cracks, because the edges has got compressive stresses and the center line has got tensile stresses, and that results into this kind of defect. So, in rolling you have to control the whole process very precisely so that these kind of defect does not appear. Other characteristic that is expected as far as the residual stresses are most often come. So, residual stress produce because of the compressive residual stresses on the surfaces, tensile stresses in the middle portion as I said, and therefore residual stresses also very detrimental. As far as the quality is concerned, tolerances, that is the gauge we call, the thickness should be uniformly distributed everywhere. So, the sheet, when you are rolling it, the longitudinal thickness everywhere and transverse thickness, usually we measure it in terms of the tolerances. So, usually cold rolled sheets, we have plus minus 0.1 mm to 0.35 mm tolerances is produced. Tolerance is much greater for hot rolled plates are used, but however in cold roll it is of the order of 0.1 mm to 0.35 mm. Apart from this, the surface roughness is also very important, that is being produced after rolling. In cold rolling, that can produce a very fine finish. In hot rolling and sand have the same range of surface finish, right. So, it is the gauge number that decides the thickness of the sheet if it is identified by a gauge number. So, that is the as far as the basic thing for measuring the different thickness. This slide shows some of the schematic illustration of various roll arrangements, right. So, you can see in the first where the roll is the shifting the mill. See, the one side is tapered and it is crowned to the roll shift, you can see. So, that is another arrangement. Now, other see the S crown roll shift. So, it is kind of S crown, this is called as. In the first it is one side tapered and crown, and another is S crown roll shift. You can see in another which is called as the cigar shaped crown roll shift, it has a different applications, and the another we have introduced the intermediate roll shift, one can see. So, these are all different varieties of the roll arrangements schematic. As far as the crossed roll 4 high rolling mill, if you look at, you see the arrangement is slightly tilted, right, and that is because of the backup roll cross mill, we call it. Second variety may be the work roll cross mill, and another arrangement of the roll is pair roll cross mill. You can see it is the cross one in pairs, you see. So, these roll arrangements are very popular in rolling. This slide illustrates the various roll arrangement further, that is used in 2 high rolling mill A, the B is for the 3 high rolling mill, C is for 4 high rolling mill, and D is your that is used in cluster mill. You see the cluster mill where the backing bearings, the housing, the driven roll, the bearing shaft, the first intermediate roll, and then the work roll, and the very important is the second intermediate roll and the driven rolls, that is important. So, the seat which it passes through the secondary second intermediate rolling mill and it comes up. So, the advantage of these is that you are able to produce a very high surface finish on the seat, and very uniform rolling takes place with this kind of cluster mills. Also, there is a very little deflection of the rolls, because there are lot of backing rollers apart. As far as the shape rolling is concerned, as I said, the different operations, various shapes can be produced by shape rolling, like you can produce bars, you can produce channels, I-beam, railroad, H section, and all those things. Roll pass design is very important. So, for the shape rolling process. So, the roll pass design requires considerable experience in order to avoid external and internal defects, right. And as I said, the roll pass concerns the designing of the groups, different groups, setting of the different arrangements of the rollers, including the horizontal rollers, vertical rollers, and displaced rollers as shown in the previous sections. There are different stages in shape rolling, as if you look at the H section rolling here, the various other structural sections such as I and as I said can be followed. So, now you see in case of shape rolling, as previously a slide concerning the flat rolling we considered, this slide shows the shape rolling process and different stages. How do we, and let us take the same example for the H section to produce. So, what happens? It starts with a bloom. So, we can start with a bloom, and then this bloom will have the beam blank. We may have a beam blank out of the bloom, and this beam blank goes to the reheating furnace, where the stabilized temperature for few hours are kept. So, the grains are stabilized, then it passes to the descaler, as previously also in the flat rolling explained. So, after descaling, it passes to the roughing mill, as see. After roughing mill, it passes to the intermediate rolling or universal mill, where there are few intermediate rollers and edging mills as well as. So, edging mills, the purpose is to reduce in the proper size of the edges to maintain, and so that there is no crack develop. After that, it passes to the finishing mill, which is called as the universal mill, where you obtain the proper shape. So, in the edge section, the web part, the thickness part, and the flange part is very important. Okay. Once you get the product out, it has to be cooled and all that, and usually if you look at the intermediate rolling and universal milling, it is a number of stages are there. So, if you look at what happens in the universal rolling mill for this particular edge section, this is shown. So, now you see the horizontal rolls and vertical roll arrangements. So, the horizontal rolls and vertical roll arrangements will give the output one by one, and how it comes out. So, there are different sets of horizontal roll and vertical roll in each stage. For an example, if you have the beam blank as initially, how it passes through, look at. So, beam blank is it breaks out in the breakdown mill, as said earlier, you see. Then it passes to the universal mill, where it is combination, it has the combination of horizontal roll and vertical roll, and then it passes to the edging mill, which I said. So, you have the edge, and then it passes to the universal mill to produce the final finished product. Okay. So, this is what the intermediate, you have lot of cooling, lot of spray and all that, lot of straightener, there is online monitoring as well, and this whole process goes continuously. So, that is how a very simple example of shape rolling. Let us come to the another variety of the rolling, we call it as the ring rolling. So, ring rolling is very often to produce rings. So, you have a thick ring which is expanded into a large diameter ring. So, the ring is in fact placed between the two rolls, one of which is driven, and the thickness is reduced by bringing the rolls together. The ring shaped blank may be produced by either by cutting from the plate or by piercing or cutting from a thick walled pipe as well as, right. So, various shapes can be produced by shape roll. As I said, the typical application of the ring rolling is a large ring for rockets, you know, gear wheel rims, ball bearing and roller bearing races. This is all produced by ring rolling process, and it can be carried out at room temperature. It has short production time, and one can obtain a very close dimensional tolerances. This is what's the basic of ring rolling process. You see the main roller, the red one, then you have the rounding rolls, and then you have the edging rolls, two edging rolls. So there are three varieties of rolls here: the main roll, then the rounding roll, the idler roll, and the edging roll, you see, and the workpiece is the green one. Now you can see. So the ring rolling operation, where you have the thickness reduction results in an increase in the part diameter, and then in the secondly, the example of such cross section you can see here. So initially it is reduced from that section to that, and then finally it is produced. Okay, so that's the basic process of ring rolling. There is another very interesting rolling process, we call it as thread rolling, right. So thread rolling, it is a cold forming process in fact, and where the straight or tapered threads are formed on round rods by passing the pipe through different dies. Basically two sets of dies are used. Typical products include screws, bolts and all that. You see the process here. You have a part that is to be rolled, and you have a secondary die, and you have a moving die, right, and you have the blank. Now see, these dies has got a groove cuts, and these moves, and so you can see the other stationary cylinder one and the moving cylinder die, and how the work is resting on work rest, and that's how the process takes place. So thread rolling are rolled in fact soft conditions. Threads may then be heat treated also and subjected to the final machining or grinding operation. The uncommon or special purpose threads are also machined if it is required. So you can see the diameters of the bar, and after machining it comes out. So this is what the two section. As I said, this to produce tubes, pipes with the help of rolling, that is also possible. So production of seamless pipes and tubings are very common. Like you see here, this slide shows the rotatory tube piercing, that is we also call it as Mannesmann process, and this is in fact a hot working process which produces long thin walled seamless pipes of metals, and it is basically carried out by using an arrangement of rotating rolls. The tensile stresses develop at the center of the bar when it is subjected to the compressive forces. Like if you see the seamless, for producing seamless tube you start with a billet. So these billets are heated, and then it passes through the Mannesmann process, and that is a set of piercer arranged, and it passes through that, and then there is a elongator, it passes through the elongator unit, and then it passes through the plug mill. So plug mill starts making a small penetration, then it passes to the reeler, and then again it is reheated, and then it passes to the sizer. You can see, okay. So that is the reverse one. Now if you, so in case of seamless piping, what you have, you must start with a sheet basically. So the usually you have you can start with your reheating furnace of the sheet, then it passes through, then it comes out to the forming where, and then the set of the rollers are there, and then it turns, the sheet turns into, and then there is a butt welding zone where those, after turning, the butts are welded and it is further reduced, the tubes, and then it further passes to the sizing of the tubes, and then again reheating again, and then again plugging to give the internal sizing, and then elongator to elongate to give the thickness of the tube in proper manner, and then piercer to pierce and bring it to the final shape, and then heat, and then we get the things, okay. So that is the seamless tube production. Another route which we call as the hot extruded pipe. So in case of hot extruded pipe, we start with hollow billets, right, and then again we heat it, and then we penetrate mandrel through the dies, and there is a rolling, there is a mandrel as well as hot extrusion takes place in fact, and then we get seamless pipe. There is a ERW pipe as well as you have, you start with the sheets, like then the forming to the bending of the tube in a proper manner, and then ER welding, that is you have the weld, and then once it takes the shape of the weld and closes, you weld it, and then again shape, and then the bead cutting is there. So that is the usual ERW piping. The spiral piping is another example for producing seamless piping. So you can see the trimming, and then the inner and outer hot rolled coils, submerged arc welding is used, and then it comes out to be there. There is another example for producing piping is by UO pipe we call. So you have a U press, like you press the sheets through the U press, and then O press, you make it closed, and then you make the submerged arc welding, that is at the inner as well as outer way, and that is how also you get a tubes. So these are the varieties of ways for producing tubings. As I said, in rolling process, generally the ingots we get it from the continuous casting mill, and that is integral process of the mill. When the continuous casting and milling is emerged, we call it as integrated mill and mini mills like. So this slide shows how actually happens. You get the slabs, right. So before slab, from how do we get slab out of the casting, this shows this slide. So that is called as the continuous casting process. One should know, that is how I put this slide here. So advantage is that you get a very highly automated process through the continuous casting, and that reduces the product cost as well as, and companies are converting over to this type of casting, because so this is here you get the hot chemistry are the hot metal in ladles. You see the swing tower ladle, the tower, it has ladles, and there is a device for oscillating the mold, and there is a automatic molding section. In the tandis, we call it as a tandis. So this hot metal from the ladle, it poured into the tandis, and then it comes to the mold. So these molds are vibrating, and there is a very smooth die inside, and when it passes through that, these hot metal gets solidified in that, and it comes out of that. So this plate, in the form of plate, it comes out, and through the rollers at proper temperature it passes through, and then there is a electromagnetic stirrer, so that solidified metal, it comes out, and there is a lot of spray nozzles for cooling the because in the tandis temperature is around 1700 degrees centigrade. When it comes to the molding, it is around 1000 degrees centigrade. So after molding, when the slabs comes out of the mold in solidified pipe, temperature may be around 1200 degrees centigrade, and so it has to be cooled further, and there are then supported roll, it passes through, and the whole slab comes out through the dummy bar, and there is a torch cutter. After it comes out at the stage, with the torch cutter, these slabs is cut into around 10-meter length. So these slabs, and these slabs then further goes to the tunnel furnace, where the temperature is further stabilized, and that slab is sent to the rolling mill. So that's the before rolling mill, how we get these slabs by continuous casting process. This is very interesting process, and one should see it. So the continuous casting and integrated mills are integral part. Generally these integrated mills utilize everything from the production of the hot metal to the casting and rolling of the finished products. In case of mini mills are also there, so one can start with the scrap metal is used, and it is melted, and then it is further casted continuously and rolled directly into the specified lines of the products. Each mini mill in fact produces one kind of rolled products, like one line will produce only rods, another line may produce only bars, another line may produce some structural shape as well. So these are called as the mini mills. Okay. So for small scale industries, for small or in medium class industries, the mini mills are very common. So as far as development of a rolling process, usually simulation is also very important, we come across, and that is used for design of the tools, which is used for improving the rolling process, etc. So this may be discussed, but I hope the simulation process has become very important nowadays for designing these all kind of rolling processes we discussed. Either you take flat rolling, either you take shape rolling, either you take ring rolling or your thread rolling. The simulation process, and especially finite element method simulation, has become very common for designing the whole set of different stages of rolling process. So I hope we covered today a lot about the basic of the rolling, and the analysis part we will discuss in the next lecture. So the analysis is also important, because a good designer must be able to design the rolling, and that will give you the application of the yielding, then how much the roll gap, all the different design issues are important. So I would like to thank you all for keeping patience here and listening. But the only thing is, please do not forget to give your feedback, because these are all web based lectures. It is being for your benefit, so you don't forget to give your feedback, so that we can improve upon for your benefit. Okay, so I thank you all once again for your cooperation. Thank you very much.